All you guys do attention span only lasts 30 seconds. So I think I need to start doing that. Yes. So this one for sure longer than 9 seconds. Yes. Um, okay, I don't know which things that we did. Okay, let me check. Maybe here. Oh, there is. Okay. So which question you want me to go over? Which one? The last one, sure. We say find out the equation that does this. This one here. So all the x-intercept is gonna give you some type of curve. Is that okay? Is that okay? So this is what kind of multiplicity is that? That's actually 3, because it looks like a waterfall. It looks like x cubed graph. So this one in multiplicity is 3, but this one's gonna be x minus 5 to the third. Is that okay? And this one is what? Square, so it's x minus 2 square. This one's what? X plus 1 to the first, right? And this one's x plus 3 to the first. Is that okay? So that should be f of x equal to a times x plus 3, x plus 1, x minus 2 to the second, x minus 5 to the third. Do you have this? The only thing that we don't have is the a value. So what is the a value? Well, a value is decided by another point. Now, which things that I know in here that offer me another point that's very obvious? The y-intercept, right? So that means f of 0 is equal to negative 12. So that means negative 12 is equal to a times 3 times 1 times negative 2 to the square times negative 5 to the third. Is that okay? And I can solve for a. So negative 12 equal to a times by 3 times 4, which is 3 times 4 is 12. 12 times 125. So it'll be 12 times 125. Is that okay? And I think it's negative, right? And then so a is equal to negative 12 over 125. So the answer should be negative 1 over 125. So this go back, replace the a. And hopefully we did this correctly. Hopefully. I don't know how accurate is this, but long as those 1, 2, 3, 4, 5, 5 point is indicated. Rest of them, long as they have general thing. Now I want to show you here. Let me take a picture of that and I can type in later.
Shouldn't the negative cancel out?
Negative cancel out?
Yeah.
Okay, negative cancel out, you're right. There's a negative sign here, cancel out completely. So this is a 1. Okay. So what we're gonna do is we're gonna take a picture of this. We're gonna type in the decimals, and so the decimals is gonna be, well, first of all, let's type in let me check the graph. Okay, I'm gonna type in 1 over 125, and I'm gonna type in, check out what we type in, x plus 3, and you see that there was x-intercept. Wait, hold on a second. Why is like this? Oh, x plus 3. Okay, and then x plus 1, and then times x minus 2 to the how many power? Second, and then to x minus 5 to the third. And let's just check out the graph here, but maybe a little bit negative, maybe 500 to 500. 500 is too big. Let me do, oh, this is negative 500. 500. 500 is too big. So let me go with negative 200 and positive 200. Maybe do it negative 100. Negative 100 over positive 100. There you go. Like it has all the characteristic and also have negative 12. This all the same characteristic, which is not exactly the same. I only want you to fit this, 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 this. You know, some graph may be a little bit off a little bit, but most of the things match. Is that okay? Because if you have y-intercept, that means you have a defined point to get it. I want to talk about one more question is this one. I see some people didn't do this one. And what I'm gonna do is, hey, I'm gonna factor as much as I can. And some people says, Mr. Yu, how do I do the leading coefficient test? Well, this is the leading coefficient. How do I write down the limits thing? Can somebody help me? Limit as x approach what? X approach negative 30, that means the function's going to the left. And it's going to what? Negative 30. Now we did this on the before. This is positive, this is odd. Positive and odd, that means y equal to x is also have positive and odd. Right? 1x is positive, odd is 1, right? And that means I'm going to the left side of the graph, the function is going to go down. This means going to the left, because x approaching negative 30, the function is going to go down. Am I going too fast? And what happens if you have limits as x approach to positive infinity? Positive infinity. And this is how you write it. So that means it's down, up. In general graph, it's going to be like this. You have 3x intercept, which has happened at 0, negative 3, and 3. The function is going to go down, the function is going to go up. So like this. And now have multiplicity 1. So even though this is not in factor form, I still can graph it. Because I can factor it. You guys already know how to factor. Any other question you need me to go over? Once you go over it, you should check the decimals graph. See if you are right graph. If you're doing good, then it's fine. If you're doing bad, that's not good. 1 to 3, 1 to 4. Any question I need to go over? I'll go over one more if you need it. So Risa, are you okay? Do you check your graph on decimals?
No.
Isaac? It's good? You think it's good? Okay. Now, sometimes we're going to start with a quadratic formula. Just so you know, in quadratic, you got three different type of situation. Let's say we're going to show you what kind of situation of x. F of ax squared, and you're going to say, why do I go back to talk about quadratic again? Because it actually gives you a lot of information in terms of quadratic. Do you guys remember the discriminant? What does discriminant tell you? First of all, what is the discriminant? Stuff inside a square root, which is what?
BC squared.
Okay, so when b squared minus 4ac is greater than 0, how many real solutions there are? Two real solutions. You probably saw it on this SAT you take last week, do you? Isaac, did you see any discriminant questions?
I think there was one.
There was one? What happened if b squared minus 4ac is equal to 0? What happened b squared minus 4ac is less than 0? Two, so there was no real solutions, right? And there is a two imaginary or complex solution. So there's two complex. Let's talk about complex solutions. So, for example, and I'm gonna say this is actually interesting. Two complex solution. The way I kind of tell people is this. If you have your solutions imaginary, have an imaginary number, they usually come in pairs. They usually come in pairs. So, I don't know. I usually make fun of people. I say if Diego were to have imaginary girlfriend, then it's better to have two imaginary girlfriend, right?
Yeah, for that actually only have one. Only have one girl.
I like Diego. Diego is a really cool person. I only make fun of people I like, so it means I like you, Diego. That's good.
Said he don't like all of y'all.
I just like him more than the rest of you guys. So I like to pick on Diego. So if you have a complex solution, it always come in pairs. And I'm going to show you why they are. For example, that's x squared plus 1, right? Do you see any x-intercept here? If I graph it, right? If I graph it, this is a parabola. Do you see any x-intercept? Do you see any x-intercept? No. But remember who invented the fundamental theorem calculus? Fundamental theorem of not calculus, of algebra, sorry, of algebra. Okay, fundamental theorem of algebra tells me that if there's a 2, that means there is two x-intercepts, there's two solutions, there are two roots, there are two zeros. Okay, tell you there is two zeros. But how come it's not on the graph? It's not, because they don't have x-intercept. But it doesn't mean that there's no two zeros. if you really set this one equal to 0, and if you move it to -1, and you square root both sides, and that's equal to plus minus I, and you're gonna be like, wait, what does I look like? It turns out, in normal situation, that we're not able to show you on the real axis. On real axis, you cannot see what's going on. So I will show you a video that does a very good job, like better than me. So I'm going to show him what he did. Have you show you before the Welch lab? I did. Okay, I want to show you again. No. Let me show you. So this is a video that is very
and like the ball is free. I get more value out of the ball than like this freaking $4,800.
Let's say we're given the function f of x is equal to x squared plus 1. We can graph our function and get a nice parabola. Now, let's say we want to figure out where the equation equals 0. We want to find the roots. On our plot, this should be where the function crosses the x-axis. As we can see, our parabola actually never crosses the x-axis. So according to our plot, there are no solutions to the equation x squared plus 1 is equal to 0. But there's a small problem. A little over 200 years ago, a smart guy named Gauss proved that every polynomial equation of degree n has exactly n roots. Our polynomial has a highest power, or degree, of 2, so we should have 2 roots. And Gauss's discovery is not just some random rule. Today we call it the fundamental theorem of algebra. So our plot seems to disagree with something so important, it's called the fundamental theorem of algebra, which might be a problem. What Gauss is telling us here is that there are 2 perfectly good values of x that we could plug into our function and get 0 out. Where could these 2 missing roots be? The short answer here is that we don't have enough numbers. We typically think of numbers existing on a one-dimensional continuum, the number line.
Sleeping?
All our friends are here. 0, 1, negative numbers, fractions, and even irrational numbers like root 2 show up. But this system is incomplete. And our missing numbers are not just further left or right. They live in a whole new dimension. Algebraically, this new dimension has everything to do with a problem that was considered impossible for over 2,000 years, the square root of -1. When we include this missing dimension in our analysis, our parabola gets way more interesting. Now that our input numbers are in their full 2-dimensional form, we can see how our function x squared plus 1 really behaves. Our function does cross the x-axis. We were just looking in the wrong dimension. So why is this extra dimension that numbers possess not common knowledge? Part of the reason is that it has been given a terrible, terrible name. A name that suggests that these numbers aren't even real. In fact, Gauss himself had something to say about this naming convention. So yes, our missing dimension is comprised of numbers that have been given the ridiculous name imaginary. Gauss proposed these numbers should instead be given the name lateral. So from here on, let's let lateral mean imaginary. To get a better handle on imaginary, I mean lateral numbers, and really understand what's going on here, let's spend a little more time thinking about numbers themselves. Early humans really only had use for the natural numbers, that is 1, 2, 3, and so on. This makes sense because of how numbers were used. So to early humans, the number line would have just been a series of dots. As civilizations advanced, people needed answers to more sophisticated math questions, like when to plant seeds, how to divide land, and how to keep track of financial transactions. The natural numbers just weren't cutting it anymore, so the Egyptians innovated and developed a new high-tech solution, fractions. Fractions filled the gaps in our number line and were basically cutting-edge technology for a couple thousand years. The next big innovations to hit the number line were the numbers 0 and negative numbers. but it took some time to get everyone on board. Since it's not obvious what these numbers mean or how they fit into the real world, zero and negative numbers were met with skepticism and largely avoided or ignored. Some cultures were more suspicious than others, depending largely on how people viewed the connection between mathematics and reality. And this is not all ancient history. Just a few centuries ago, mathematicians would intentionally move terms around to avoid having negatives show up in their equations. Suspicion of zero and negative numbers did eventually fade, partially because negatives are useful for expressing concepts like debt, but mostly just because negatives kept sneaking into mathematics. It turns out there's a whole lot of math you just can't do if you don't allow negative numbers to play. Without negatives, simple algebra problems like x plus 3 equals 2 have no answer. Before negatives were accepted, this problem would have had no solution, just like we thought our original problem had no solution. The thing is, it's not crazy or weird to think these problems have no solutions. In words, this algebra problem basically says, if I have 2 things and I take away 3, how many things do I have left? It's not surprising that most people who have lived on our planet would be suspicious of questions like this. These problems don't make much sense. Even the brilliant mathematicians of the 18th century, such as Euler, didn't really know what to do with negatives. He at one point wrote that negatives were greater than infinity. So it's fair to say that negative and imaginary numbers raise lots of very good, very valid questions, like why do we require students to understand and work with numbers that eluded the greatest mathematical minds for thousands of years? Why did we even come to accept negative and imaginary numbers in the first place when they don't really seem to be connected to anything in the real world? And how do these extra numbers help us explain the missing solutions to our problem? Next time, we'll begin to address these questions by going way back to the discovery of imaginary numbers.
So this is for people who like enjoy math. This has a lot of interesting math in there. But anyway, yeah.
Can a solution have one imaginary number?
Last time, we left off wondering how imaginary
Great
numbers
question.
could help us find the roots of our equation x squared plus 1.
Um,
And further, how imaginary and negative numbers even became part of modern mathematics after being avoided and ignored for a couple thousand years.
So that's a great question Sophia posted. Can a question to be a one imaginary solution? As far as I know, the imaginary friends usually come in pairs. As far as I know. Now, you may be in later to invent the new math that you can have one imaginary solutions. I don't think so from what I know. So like I said, I'm not a person I'll claim that I know everything because I don't know. Because a lot of part of math is not even invented. A lot of you guys will become future mathematician or future whatever. You guys will invent those part of math. But as far as today, I will tell you far as today right now in high school and even somewhat half throughout the college, it's gonna be imagined solution. They always come in twos. They always come in two. And reason why it's always like this. Imagine like this, right? If I have some type of factor, right? If I have x squared, x, I have some type of polynomial, x minus 1 squared, x plus 4 to the third, and then x squared plus 1, right? So this has total of 7 degrees, right? But this one, it's not showing on the graph. And not only not showing on the graph, so this is not show on real graph. On real graph. Because if I graph this, I'm not gonna find any x-intercept. Just from this particular part. And also if I were to do quadratic formula for this, so imagine that's x squared plus 0x plus 1 equal to 0. Quadratic formula is negative 0 plus minus, right? 0 squared minus 4 over 2 times 1. Imagine that, see, this is a plus minus. Why they come in 2? One is positive, one is negative. Right? They always come in solution. So that's going to be negative 4 over 2. Do you see that? And that's why you're going to get plus minus square root of negative 1 times 4, which is 2, which is times square root 4 over 2. And that's what's going to give you plus minus I. Plus minus I. So they always come in two. So imaginary solution always come in pairs.
What if it's 0? Then both of them will be the same.
What if what?
If it's like 0, the plus and negative won't matter.
Yeah, if a plus, yeah, so that's why you have one solution. If you have discriminant is 0. So that's why a lot of people say you need to memorize things. You don't. If it's the b squared minus 4ac is 0, that means you radical 0. Radical 0 is just a 0. So the answer is just going to be b over a. Does that make sense? So what today's homework was a little bit tricky. So I say there is a 7th degree of the function. So this a function has 7th degree. Okay? And I will tell you let's not do 7 degree. Let's do 5 degrees. Let's do let's just say we're gonna say 5. Okay. So 5th degree of the functions. So this function had 5th degree. It also have a 0 at 3 and 0 at -1 and 0 at -4. Okay, I have this. And also gonna give you an answer is equal to x equal to 3i. X equal to 3i. So how many 0 I have right now? How many is 0? Well, 4, right? Well, it's on paper is 4. But since there's a 5th degree, it must have 5. So where's another 0 at? -3i. So x equal to -3i is not presented because this is inferring there's another one. Yes. Sure. Inferring there's another factor there. So can you find this polynomial? Let's just say, can we find the polynomial? Actually, matter of fact, let me give you another information. 3. Okay, so let's say f of 0 is equal to 216, like this. Can you find the polynomial based on those information? Is it possible to find a polynomial? It turns out we can work backwards. Imagine there's x-intercept at 3. What will be the factor? X minus 3. Think about it. I just subtract 3 on both sides. Move the 3 over, right? That becomes a factor. Does that make sense? Does that make sense for everybody? This is very important SAT ideas. If you have a 0 at 3, your factor must be x minus 3. Is that okay? If there's a factor at x equal to negative x, if you have 0, x equal to -1, what's my factor? X plus 1. Is that okay? That's called factor theorem. X equal to -4. What does that mean? X plus 4. Is that okay? Am I going too fast? This should be fairly easy. And what will be the factor of this one? Come on, same idea. X minus 3i. That's what I said. Diego's a genius. It's 3i because just move the 3i to the other side. And guess what? This one has offered another one, even inferring If a complex solution, if you have one complex solution, there must be a second one following. So what is this one called? X plus 3i. Also, this is f of x is equal to this, right? Obviously, there's an a value right here. We don't know what an a is. But then let's go find it. But before we're doing that, I always prefer to join those two factors together. Because if you join those two factors together, it's going to come up pretty nice. I will show you how to multiply those two factors. So x minus 3i times x plus 3i. Now, if you know, this is called difference of square. But if you don't, that's okay. That just work out in a traditional way. X squared plus 3ix. Do you see that? Minus 3ix minus 9i squared. Do you see that? What happened with 3ix and 3ix? And that becomes x squared plus 9. Do you see that? So then you got x minus 3, x plus 1, x plus 4, and x squared plus 9. And that's some type of f of x. So how many degrees is this? 1, 2, 3, 4, 5. So when you ever have something that's plus 1 here, you're gonna guess what? You're gonna have that's two imaginary solutions. Now we want to find out an a. Is it possible to find out an a? Because we have this, right? So it'll be 216 equal to a times negative 3, because 0 minus 3, 0 plus 1, 0 plus 4, and then 1. 0 plus 1. Is that okay? That's 9, sorry. Right, let me erase that. So let me delete that. 9, right? Is that okay? So it'll be 216 equal to a times negative 3 times 1 times 4 times 9. Well, that's end up to be 36 times 3. I think it's 108. Is it? A times negative 108. And a is equal to negative 2. End up by finding this new polynomial. Says f of x is equal to negative 2 times x minus 3, x plus 1, x plus 4, and x squared plus 9. And if you distribute everything else, I usually combine those two first, so it makes it easier to evaluate. So you actually find a polynomial. And yes, it can only become in pairs. And sometimes a little bit more difficult than this. A little bit more difficult than this. So then that's not only that this can come in pairs, okay? So I will say, I'm gonna emphasize on what Sophia says. Sophia says if it's I, then they come in pair. Not only that, in i's come in pair. Actually, any irrational roots, they come in pairs. So for example, if you have discriminant is 5, then you have 2 plus minus root 5 over 2. That always come in pair as well. So if you have 1 plus root 5, there's another one is 1 minus root 5. Same thing as the imaginary number. 1 plus 2i, then 1 minus 2i is the answer. Got it? Okay, so I'm gonna give you a question, see if you guys can figure out. Let's say this is third degree. So very, very small degrees. We have x equal to 2 and x equal to 2 plus I. and we says f of 0 is equal to 36. Can you find out this polynomial? What is this inferring? What's another complex solution there are? 2 plus I, what's the other one? 2 minus A. This is called conjugate pairs. Is that okay? Can I change this to factor form by moving everything to the other side? X minus 2 minus I equal to 0. Is that okay? X minus 2 plus I equal to 0. Is that okay? And X minus 2. So that's pretty much is f of x is equal to a times x minus 2 times x minus 2 minus I times x minus 2 plus I. Now what you can do is here you're gonna say, well, how do I simplify this? On the other side it's kind of ugly, but there is an easy way to do this. By think about this is a fact, this is a parenthesis, because the order operation should be that inside the first two should be a parenthesis anyway. Now you know this is A, this is a B, this is a A, this is a B. You know when you multiply this together, it's gonna be what? A squared minus B squared. Does that make sense? Because that's what? Difference of a square, right? Is that okay? So it's gonna be x minus 2 squared minus I squared. What is I squared? -1. So that's going to be a times x minus 2 times x squared. Sorry, not x squared. X minus 2 squared plus 1. So now I actually take those two complex solutions and join together. They actually go away. But what you can have to do is you have to parentheses first two term, and then you can say, oh, okay, that's just the difference of a square. If a difference square, that's going to be a squared minus b squared, so it'll be x plus 2 squared plus 1. How many of you guys don't understand this? Sydney, you look like you don't understand. Okay, then you gotta raise your hand. Okay, thank you. Look, it takes a lot of guts, says I don't understand. But that's better than people pretend that they understand and they have no clue when they go home. If you don't understand how to do something, always ask. One day you're gonna get a job somewhere, and if you don't understand something, you're gonna ask. You're gonna say, hey, how do I use this printer? Better than try to figure out and broke the printer. And that's what happened with most of the people. I don't know. There was actually a talk about this before. Okay, so what happened is I can, if you have 5 minus 2 plus 1, what happened first? 5 minus 2 happened first, right? So can I just rewrite as a parenthesis? It's still going to give me the same answer, right? So what happened is I'm going to write parenthesis on the first two term here. The reason why is because I see this is a minus b and a plus b. So imagine that if I would have just do this, right? If I just do this, multiplying, so this multiply this, what am I gonna get? X minus 2 square, right? That's gonna be plus I times x minus 2, right? Minus I times x minus 2, right? And then minus I squared. Is that okay? So what happened to this two? they cancel out still. So eventually it's going to be x minus 2 squared minus I squared. And I squared is -1. So if you change the -1 to here, it becomes positive 1. Is this okay? And then you can find out what the f of 0 is. I don't know what the f of 0 is, but you can figure out now. By plugging the 0 is equal to 36 a times the -2 times 0 minus 2. So 0 minus 2 squared plus 1. So 36 equal to a times -2 times -2 squared. So it's 4 plus 1. So it's 4 plus 1 is 5. So a is equal to 36 over -10, which is equal to -18 over 5. So that's why it's going to be -18 over 5. So you figure out those equations.
Thanks for another great Titan day. Students, you are now dismissed.